yesterday. It is incredible. I'm a big Serena follower. And the best part of the Serena story is, historical Serena plays his sister Venus. I don't know if everybody knows what I'm talking about, but okay, that's been in the New York media daily. And at the end of the match, that ended up like at 11 o'clock at night, she goes to all these interviews with everybody, and the next morning, after beating her sister in a 3-set, she's up again at 8 o'clock, practicing and practicing and practicing. Organic chemistry is a bit like that. The more you practice, the better you get at it. If you don't try it yourself, as much as you understand everything I say, it will not come to you on the day of the test. You really, really have to try to do it beforehand. So, in this example, it didn't matter which way you went. Octane would have been the longest, but you had the option of coming from the left or from the right, and your numbers would have been 3, 4, 5, and 6, or 3, 4, 5, and 6. When numbers are equal, it was the alphabet, the one that made the decision of starting on the right. So that compound is 3-ethyl 4,5,6-trimethyl octane. I know it's cold, I know. It's like, oh my gosh, I love it, but I should have brought more clothing. Yes? And it would have been wrong. Is everybody hearing what Kyle said? Kyle says, well, I like to start from the left. And if you started from the left, the big difference is in the numbers. And then all of a sudden, the ethyl gets a number 6. And the answer, that would be wrong. Okay, and the decision is because the numbers are equal. When the numbers are equal, the deciding factor there is the alphabet. Because we all have to agree on the same. Okay, so you would go from the left, and then you go from the right. If you come from the left, your numbers were, right, so your numbers were 3, 4, 5, and 6, right? My numbers are also 3, 4, 5, and 6. So we have the same set of numbers. But if you start on the left, that 3 is for a methyl, and that 3 is for a ethyl, then we have to pick that one. Okay? When numbers are equal, we're going to be changing this momentarily. Okay, take a look at letter B. When we take a look at letter B, again, rule number 1 is to establish the parent. And if you go around, the longest chain would be 1, 2, 3, 4, 5, 6. Okay? So if you start from the left, your numbers would have been 1, 2, 3, 5, 5. If you start from the left. If you started from the right, the numbers are in 2, 2, 4. Because the numbers are less, then I look at the alphabet. Okay? So that's the decision. So over here, numbers 2, 2, 4 are lower, right? And the beginning is right here. You don't have multiply, divide, do integrals. All you look is at the first number. The first number being the lowest, that's overall it. And then you just organize the name in alphabetical order. Yeah? All right, so the name is 4-ethyl 2,2-dimethylhexane. We go to letter C. I think this one was very simple. I think everybody had no troubles with this one. This will be your 2, 3, 4 trimethylpentane, right? So 2, 3, 4 trimethylpentane. So I think this was okay. I get to letter D. And we have to find the longest continuous chain. And the longest continuous chain looks to be like that. So this one here is the point of attachment. That becomes your carbon 1. Okay, the moment that you're taking that carbon and you're attaching it to there, that's your carbon 1. If you have a substituent on 1, you have to start right there. Okay, if there is a substituent on 1, that is your start. Okay, so that will be number 1. Then you have 2, 3. So you have substituents on 1, 3, and 4. 1, 3, and 4. They all are cyclos, right? So they all are cyclos, so then you have to look at the other word. One is cyclobutyl with a B, the other one is cyclop, so it PE will be alphabetically before PR. So it will be the one cyclobutyl, the one cyclopentyl, the four cyclopropyl, and at the end of all of that, your hexane. Any questions on this one?
Just a quick question. So if you're long, so if it wasn't a cyclohexane, it was a cyclo, it was just a butane, right? Would you go with the cyclopentane as your longest, or no?
If you have a cyclopentane and that's only a butane.
A butane and the two other groups, would you go with? So your longest chain, would that be the cyclopentane, or still go with the butane?
So you have this, and now you have that. 1, 2, 3, 4.
Yeah.
And now you're putting here that.
Yeah, like another substitution, right?
More than likely, you probably will keep the chain.
Still keep the chain.
This becomes a real nightmare to name, you know?
Okay.
Yeah.
I'm just confused by your numbering because I thought one would be on that corner. Yeah, I thought it would be a heptene. I kind of thought first, yeah, it's all essentially.
Right. So what happens is like you really have taken a cyclopentane, you took a hydrogen off, and you attach it to a carbon. And then that carbon then becomes your carbon 1. So it's like you took a 1, so that's 1, 2, 3, 4, 5, 6, and on that carbon 1 you took a hydrogen. You can't make the carbon of the ring be carbon 1, because the carbon of the ring actually just lost the hydrogen and it's holding hands with this one. Okay, so on carbon 1 you attach that one, on 2 and 3 you put this guy, and on 4 you did this. So it's like you really took a molecule of hexane, everybody? You took a molecule of hexane, and you took a hydrogen off and you put a cyclopropyl. You took a hydrogen off and you put a cyclobutyl. You took a hydrogen off and you put a cyclopentyl. Okay, so that then becomes a carbon 1. Anything that you take out of carbon 1, that will become then your number 1 position. Yeah? Yeah? Okay. All right. Let's take a look at letter E. If we look at letter E, we have two substituents. Again, this is the same story of 1 and 2 and 1 and 2 pile. So this is the same thing that you can have 1 and 2 and 1 and 2. And when the numbers are equal, then the alphabet calls it. So this compound will be called 1-ethyl, 2-methyl cyclopentane. Give you the name for that one.
Why is the whole chain
Are we back at D or at E? Where are we? At E? Okay, when you have a ring, the majority of the time the ring is the parent. Okay, so I think your question that Israel was saying will be like the better question. If the ring is 5 and the substituent is 4, the ring is the parent. Okay, so if you have a 5 ring and 4 side, the larger the number is the parent. Okay. If you have a 4 chain, and you put a ring, and that 4 chain can be broken, there'll be an example, then you want the ring to be the parent. Most of the time, the ring is the parent, unless the chain is longer, like the example before. In this example before, the chain is 6, and all the rings were smaller than 6, so then the chain is the parent. In this example, the chains are only 2 carbons and 1, so the ring is the parent. I mean, imagine trying to name that as the 2. It's, so there's like that element of like, how would you name it if it wasn't a ring? So the idea of the ring is that you took a hydrogen off the ring and and you attached an ethyl, and you took another hydrogen off the ring and you attached an ethyl. So you've substituted your ring with these little substitutions. Like take a look at this one, for example. So here is that what I was just saying. This ring is only 3 carbons, while the chain is 5. Right? So the chain here is 1, 2, 3, 4, 5. The chain is longer than the size of the ring, then the chain is the parent, and the ring is a substituent. So then that one becomes 2-cyclopropylpentane. Okay, so that's your 2-cyclopropylpentane. Is everybody okay? All right. Letter G. Letter G. Okay, letter G is here. And letter G is this classic example that we want to go ahead and name the old way. And so if we were to go the old way, we're doing both. So don't jump off the bridge. We're doing both. It's much easier for me to call it 1-isobutyl, 3-isopropyl cyclopentane. Okay, like this little bit of time, we're doing like translations, okay? So this will be like another way of looking at it, that we're looking at translation. I'm giving you the old way, and you have to go to the new way, or vice versa. You're going from the new to the old, or the old to the new, okay? So I'm gonna call it 1-isobutyl, 3-isopropyl. Take a look at the reason why I called isobutyl first is because of the B in isobutyl. No drinking is allowed, but I'm sorry, my voice. Or the isopropyl. I have my $4,000 saved away from my debt when they come in and tag me. I think it's $4,000. If the school, if there's an infraction, even if there's a wrapper, if they come in and there is a wrapper in any of the trash cans, we will be charged $4,000 per wrapper.
That's great.
So I have the 4,000 OSHA thing. Well, actually, no, I'm giving it to UCSF. All right, so that's what I call the 1-isobutyl, 3-isopropyl cyclopentane. If you had gone the new way, which is what we wanted you to do, right? We wanted you to use the new nomenclature. Your isobutyl is then your 2-methylpropyl, right? Isobutyl is 2-methylpropyl, while your isopropyl is 1-methylethyl. So alphabetically, methyl ethyl would be first, so that guy then becomes number 1 because numbers were equal, right? Numbers were equal. They would be 1-3 or 1-3. So the new nomenclature now switches the order of things, and the correct name is going to be 1, parentheses, 1-methylethyl, and then 3, parentheses, 2-methylpropyl cyclopentane would be the name for that one. Is everybody okay? You need to know both. And everybody can see that we switched the order of things, right? Everybody can see that we have switched the order of things simply because numbers were equal, and it is the alphabet, the one that is going to decide that we're all going to have the same answer. Yes? All right. Take a look at letter H. And I did it the same way. I started with the old, and I called it the 1-ethyl 3-isobutyl. I started with the old. And then I went with the new. And this time when I went with the new, the numbers stayed the same. Okay, so the numbers this time stay the same. So your numbers may vary or may not. Okay, so we're putting these two examples back to back so that you realize that the numbers can be changed or remain the same. They don't have to be like you think it would be. Okay, so they can change or remain the same. Yeah. it's tert butyl, then it will be the B. Because there's a hyphen. So if it's tert hyphen butyl, it's the B of butyl. If it's sec hyphen butyl, it's the B of butyl. If it's isobutyl, all one word is the I.
Yeah.
Is everybody? The tert butyl and the sec butyl, the term tert or sec was just for the position of the carbon. So it was a secondary carbon, so it doesn't count in the alphabet, it's just the butyl. But it was a tertiary, doesn't count, it's the B that counts, because that was just the position of the carbon.
But the iso does.
Okay, we get to the very last one. And the very last one, I have 4-ethyl 1,2-dimethyl cyclohexane. Everybody get that one correct? Remember the story, numbers are first. You could have 1, 2, 4. So your numbers here are 1, 2, 4 if you go this way. Or it could be, if you follow that story of your alphabet, 1, 3, 4. Right, so those are the options. So in your 1, 2, 4 or your 1, 3, 4, the 3 is the one that's going to make the decision of going the other way. Yes?
So typically when we have tests, it's always gonna be that 1 hour, 15-minute segment, the tests.
Yeah.
Like, would you say you have true, false, no, just multiple choice and then written?
Yeah. I know, I'm having such a hard time because my tests are clear, but I'm working with a new teacher and we're trying to coordinate and whatever. Yeah, usually they're having multiple choice and workout problems. All right, is everybody okay with this one? Go ahead.
So if I put 1-ethyl 3,4-dimethyl cyclohexane, that's right.
That will be wrong. Is everybody there? That will be wrong. Rule number 1, parent. Rule number 2, numbering. Okay? So when I do the numbers, if I start the way that I did, the substituents will be on 1, 2, and 4. If we do the way you did, your substituents would have been on 1, 3, and 4. So the ones were equal, but 2 wins 3. So this is the correct order. And then you organize it alphabetically. Always. So everybody hear that? Rule number 1, parent. Rule number 2 is the numbering. So you want the substituents to be in the lowest number possible. Rule number 3 is the alphabet. I keep saying, when numbers are equal, the alphabet calls it. But that's after numbers are equal. Otherwise, you have to come up with the lowest number.
Wait, so you said lowest number, and those two are equal, so why would alphabet apply if they're not equal?
That's what I said, they're not equal. So you're looking always for the lowest number. So we're both on 1, 2 beats 3, so you have to go with that. Then you worry about the alphabet.
Okay, you're just assigning numbers to the
Substituents.
first, then you
Right, right. So when numbers are equal, back again with that same story. Over here, when the numbers were equal, 1 and 2, or 1 and 2, may I say it 5 times? When numbers were equal, 1 and 2, or 1 and 2, then we all still have to come up with the same name. Then is that you look at the substituents and their names, and then that's when you apply the alphabet. And all these stories are going to be refined as we go through. The stories will change as we go through the semester. But for now, that's the story. Okay, for now, that's the story.
Sorry,
All right.
never mind.
Oh, okay, yeah. She goes, hey, you didn't do the primary, tertiaries, and all that. All right, so here we go. I'm not labeling all of this because this is ridiculous. So we're going to concentrate on this one. How many primary carbons is that compound? How many primary carbons? People are saying 6 right away. Primaries. So that's a primary 1, 2, 3, 4, 5, 6. That's correct. How many secondary carbons do you have? There's 1, there's 2, There's 3. How many tertiary carbons do you have? There's 1, there's 2,
4.
there's 3, and there's 4. Is everybody able to identify that like that? Yeah? When I look at this one, how many quaternary carbons do you have? Do you have any quaternary carbons?
1.
Is everybody seeing that there's 1 quaternary right there that is bonded to 4? Okay, so this molecule actually have all 4 different types of carbon. Okay, it's the only molecule I think here that has all. You have primaries, 1, 2, 3, 4, and 5. So there are 5 primaries. There are 1, 2, 3 secondary carbons. There's 1 that is a tertiary, and there's 1 that is a quaternary. And I think we don't have to go through this because everybody gets it, right? Yes. Anybody does have a problem with this? Okay. All right. We're going to go to, they want you to go ahead now and draw the structure. And I want to make sure that you know that a lot of what you're going to see on exams have nothing to do with me being evil, all right? When I go to the drawing tool, and I said to the drawing tool to go ahead and draw, what am I supposed to tell them? 6-isopropyl, 2,3-dimethyl. This is what the drawing tool draws. Okay? So, I'll say it differently. Okay. I go to the drawing tool and I say draw that, and this is what I get. And this doesn't look at all like what you drew. Is everybody? What you drew would have been something like this, that you started out with a no name, and you went this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you went on carbons 2 and 3, you put your methyls. So I'm sure, 4, 5, 6, I'm sure this is how yours look like. Right? Yours look like this on the right. The drawing tool puts it like that, and it doesn't matter what I try to do, it's going to look like that. So don't fall off the chairs. When you see the test, it wasn't intentional. It's just the way that the drawing tool works. And so all you're going to do is apply all of your rules. Rule number 1, you establish the parent. Longest continuous chain. And then rule number 2 is the substituents. You want them in the lowest number possible. Rule number 3, then the alphabet. Okay? And then the 4th thing is that we really want you to convert them to the new nomenclature. And in the new nomenclature, your isopropyl is really methyl ethyl. And they do like the 1, and they call it 1-methyl ethyl. I'm going to agree that that's the way they want to do it. Okay. Letter B, the same story. When I go ahead and I say type that, what am I doing? I have so many names here. Is this the same thing? All right. Okay, let's take a look at letter B. And letter B, when I go and I type, again, I say type print 4-terbutyl, it's going to look like that. When I say 4-terbutyl, it's going to look like that. 4-terbutyl, 3-methyl, whatever, heptane, it looks like that. I cannot do anything about it. You're just going to make sure that you get your right drawing. Call it a day. So the new nomenclature is going to be then the 4,1,1-dimethyl ethyl, the 3-methyl, heptane. Everybody okay?
Yes.
Okay, I look at letter C, and letter C is your isobutyl, 4-isobutyl, 1,1-dimethyl cyclohexane, and I tell it, and that's what it looks like. So it doesn't matter who your number one is. For these types of problems, it doesn't matter, who your number one is. You know, it could be any position. What is important is that you would have them in that 1-4. So looks like that. Everybody okay? All right, and the new nomenclature, it will become the 1-1 dimethyl now go first. Did you see in the new nomenclature, the 1-1 dimethyl now go first? And then you would have on carbon 4, the 2-methylpropyl cyclohexane. So that one seems to work much better for what you have to do. Okay, you go to letter D, and letter D, oh, it looks so good. There's my sec-butyl cyclopentane. So there's the sec-butyl cyclopentane. The new nomenclature for the sec-butyl cyclopentane is 1-methylpropyl cyclopentane. And here is the beginning of problems. Here is the beginning of problems. If you only have one substituent on the ring, right? If there's only one substituent on the ring, you don't have to put a 1 in front because that's going to be your carbon number 1. Okay? All right, let's give an example of this so that everybody kind of follows. So you're going to name these compounds. Name the compounds. Okay? You're going to name these compounds. So this one on the left is going to be called cyclohexane. This one on the right is going to be called pentane. One is correct and the other one is not. This will be wrong. You have to call this a 1-chloropentane because your chloro could have been in 3 different places. The chloro could have been on carbon 1, or on carbon 2, or on carbon 3. Over here, the chloro, if it's on 1, is on 1. If it's on this one, is 1. If it's on this one, is 1. It doesn't matter what you do. All hydrogens of cyclohexane are equivalent. All 12 of them were equivalent. So it doesn't matter where you put it. It's still going to be all the same. Cyclohexane. On the molecule of pentane, not all hydrogens were equivalent. And so you have to distinguish by calling them 1, 2, or 3 for them to be clearly delineated. Okay, so the 1 will give you points or will take away points. All right, the last in this story, which was the cyclobutyl cyclopentane, will be that. And there was no other way of drawing that one. That one seemed to be easy enough, right? Everybody okay? No questions about discussion number 3? Anybody else has any questions before we get to discussion number 4? Yeah?
I just started a lot with my old meeting instead of the ones
Oh, the old maybe? We'll practice this after. The old,
Oh, this is 4.
I hate to say this, but the old, they just have to be memorized and recognize them, but we'll have a practice today, okay? All right, we're going to number 4.
Yeah, chapter 3. So chapter 3.
We're gonna go to discussion number 4.
Chapter 3 discussion.
Discussion number 4, again, we'll try to name those.
We don't know it's fine.
Okay, so we'll start with discussion number 4. Discussion number 4, we And again, we do the exact same thing, numbers are first. So the discussion number 4, the compound is 4-ethyl, no. Can't be 4. Gotta be 3, right? Did anybody notice that?
Yeah, it's 3.
1, 2, 3, it's gotta be 3. Cannot be 4, that is wrong. So it is 3-ethyl, 1,1-dimethyl cyclopentane. Everybody okay with that one? Yeah? All right, we'll go to letter B. And letter B, here's the story again. This is the point of attachment. You've attached that ring to that carbon. Okay, so it is this ring that is attached to this carbon. This becomes now your carbon number 1. And then you're looking for the longest continuous chain. So 1, 2, 3, 4. Butane is the parent. On carbon 1, you're putting a cyclopropyl. So it'd be 1 cyclopropyl butane, and that 1 is important because the cyclopropyl could have been on carbon 2 of the butane. So that 1 is very needed. You've got to put it there, otherwise it's wrong. Otherwise it's wrong, so we're putting it there. So we're calling it the 1 cyclopropyl butane for that one. Everybody okay? All right. We go to letter C, and letter C, we have the tert-butyl, we have the fluoro. So on carbon 1, we have the 1,1-dimethyl ethyl, and then there's the 2-fluorocyclobutane. So it's the 2-fluorocyclobutane for that. Everybody okay with this one? Yeah? Yes or no? Is everybody okay? Okay.
Wait. So.
And only based on the alphabet. So the D and the F based on the alphabet, which actually really brings a very interesting position, because we're saying here that your alkyls and the halogens are equal in priority.
Yeah.
So they're at the bottom of the barrel. They're going to be the only ones that are at the very bottom of our barrel. So they're equal in priority. The dimethyl is before, just based on the D of the dimethyl. So when you're in parentheses, the first letter of the word that is in parentheses is the beginning of your alphabet. So if it's a dimethyl, it's a triethyl, which I don't know if that happens, but then the T would be the first letter. Yeah. But again, what is important here is that your alkyls and your halogens are equal in priority. So there's no priority, it's just the alphabet, the one criterion that we're using to separate them, okay? So if we follow that, when you get to this one, we're doing the exact same thing. You're looking for the parent is cyclobutane, that's the parent. And then you're looking at the numbering. And when you're looking at the numbering, it's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. No matter which way you go, the lowest numbers are 1, 2, 3. Once you have established the numbering system, then, Christy, we're not going to do it. We're going to do like Thursday. You remember how Thursday we did the dry lab? So we're going to keep consistent. So Thursday we'll do that, and then we'll do the following. We're catching up with lectures. Thank you. I don't want you to work extra for nothing.
Oh, okay.
I didn't want you working hard for nothing.
We'll save it for next time.
Yeah, we're saving it for Thursday and Monday.
Okay.
All right, so then the name will be the 2-chloro 1,3-dimethyl cyclobutane. Right, so it's 2-chloro 1,3-dimethyl cyclobutane will be the name for that one. When we take a look at letter E, I think this is a classic example that question maybe would have been, I'm not even unveiling. So if you look at the ring is 4. And if you look at the longest chain is 4, right? But if the ring is the parent, and you can start the point of attachment right there, then that 4 is converted to a 3. And then that is the deciding factor that I'm gonna be the substituent and you will be the parent. Because I was able to take the side chain and cleave it into smaller pieces. Okay, so the decision is that the largest number is always the parent. Okay, so obviously I cannot chop the ring, but I can take that substituent and cleave it into what is known as a substituted substituent. And as a substituted substituent, that became your 1,2-dimethylpropyl cyclobutane. So it's a 1,2-dimethylpropyl cyclobutane. Yes? So back again, right at the beginning, this is 4, and this is 1, 2, 3, 4, right? So it may appear that this is 4, and now we all have to have the same name, right? What's important is that we all can have the same name. So what they look at, if this is the substituent that you're attaching it right there, and now you see that your chain is so much less, now it became 3 carbons, not longer 4, right? Because now I was able to chop it, now it became 3, so then that becomes the substituent, and the parent remained the 4-carbon ring. So it becomes the 1,2-dimethylpropyl cyclobutane.
So you only do that when they're equal, right?
Right. Right. And I think, Jeanette? Okay. So Jeanette saying, really, can you just put that in plain English? We're only wasting this much time when the length of the chain is the same size as the length of the ring. When they're equal, 4 and 4, and we need to come up with another layer to separate it, see if your 4 can be fragmented less. Like if you have an isopropyl one way, and you have a methyl and an ethyl, that's the correct way. I'll say it differently. This is not this example, but in another example. Is if in another example you have an isopropyl counting one way, or counting another way, you can have that isopropyl into a methyl piece and an ethyl piece, that's the way you want to go. They want the smallest substituent possible, number-wise. 1, 2 carbons. All right, we'll take a look at letter F. And when we take a look at letter F, here we go with the story with letter F. Numbers are equal. 135, 135, 135. Is everybody there? So 135, 135, 135. I think it's a good idea that you decide what the names are. I can see that one substituent is ethyl, the other substituent is methyl, and this will be called a methylpropyl, right? So I have a methyl, and then I have a 1-methylpropyl. Methylpropyl, yes. Yes or no? So those are my substituents. I take a look at the substituents, those are them. That will be the alphabetical order. Okay, so then you're carbon 1, okay, you're carbon 3, and then you're carbon 5.
So I thought the one of your parentheses was priority for alcohol.
No, I never said that. She said, you said that the one in the parentheses has the priority. Did I ever say that? I don't think so. I've never said that with priority. These guys are all equal in priorities. There's no priorities here. The only priority here is numbers. When numbers are equal, then the alphabet. Okay? So yes, you would have picked ethyl as 1, but then we have 3 and 5, and you still follow that. So then the methyl becomes the 3, the methylpropyl the 5. Yes. No. On the exam, I'm really clear. If I say, name the compounds using the IUPAC, is this methyl, ethyl, ethyl, whatever. Oftentimes, I say isobutyl for you to translate. This is much easier. I'm the typist. I'm everything. I'm the one that writes the test. I'm the one that types the test. I'm the one that prints the test. Yeah. If they all retire, I won't know what to do with my time. Probably start taking to badminton or something. My knees won't go there. So, all right. Oh, the cosmetic. All right. So draw structures. Everybody okay? Yeah, and at the end of all of that, cyclohexane, no? And at the end of all of that, cyclohexane. All right, I guess it's time to go. When we come back, we'll finish this discussion packet, and we're working. So we're working all afternoon. No work, no lab, but we're still working on everything. Okay? So we'll start right here.
Huh? Yeah, the ending was cyclohexane.